So, Guillermo, what do you know about cation resonance?
Oh, what? Sorry, I don't know anything about that.
Cation resonance? You don't know?
I don't know anything about that.
Resounding with the anions. No. Repeat. Cation. An ion is a part of a cell? No. Oh, for sure. No. That question you asked me earlier really got me thinking. Can we ask an expert?
Cation resonance means multiple structures for positively charged ions, and these multiple structures are necessary because one structure is not enough to adequately describe the electron bonding of the molecule. And in this simple, straightforward example, we'll demonstrate that the arrows should always be drawn toward the positive charge. And in drawing the arrow this way, you can see that it would result in this molecule, demonstrating a kind of basic model of cation resonance.
According to the experts, here are the guidelines for drawing cation resonance structures. Start your arrows at lone pairs or the center of pi bonds. The arrow then moves towards the positive charge. The charge then moves to where the electrons were lost. And certain aspects of structures don't change, such as the atoms, the bond angles, the overall charge, and the number of pi bonds in lone pairs.
When drawing cation resonance structures, it's important to remember that certain forms are more stable than others, and in that case, this would be the major forms. And major forms are the lowest energy and the most stable. And two ways to find the major form are to see which ones have the most filled octet or which ones have the least charges. So in this example, you can see that the lone pair from the nitrogen is moving to the sigma bond to form a pi bond. So that moves the positive charge to the nitrogen. And this one's a major form because there are more filled octets. In the second example about charges, the lone pair from the oxygen is moving to form a pi bond here, and this fully gets rid of the positive charge. So in this case, this one's the major form.
Here we have another example. So as Emily said before, the arrow always is drawn towards the plus side. So this double bond would move to here, and that would give you this structure, and the positive would move here. Does anyone else know the third structure?
Yeah, doesn't the double bond on the left side move towards the positive in the middle?
Correct, Andrew.
Now we're going to try a bit more of a complex example. The same rule still applies that you draw your arrow from the double bond to the plus charge, which is on our nitrogen. You redraw the molecule. Now the plus charge is down here in the middle, and we still have the lone pairs up here on the nitrogen, which are going to form the double bond in the middle because it's going towards the plus charge. Now the last molecule in this resonance series is going to have the double bond here in the middle, and the plus charge is going to go up on the nitrogen that lost its lone pairs. These two are major resonance forms because they have full octets as well.
Oh, so cation resonance is the multiple structures a positive ion has for stability.